All right. So you're welcome again. Let's begin. So we are doing saponification. All right. And what we're going to be looking at is some key terms, things like hydrolysis. And under hydrolysis, you're going to have acid hydrolysis. We're going to have alkaline hydrolysis. And we're going to be looking at saponification of esters, how detergent molecules work. And I think these are blocking. Let me put these on the side here. How detergent molecules work. We're going to be looking at hydrophilic and hydrophobic, and of course, soapy and soapless detergents, which I think we would have touched on a bit last class we had.
Yeah.
Okay, so we're going to move ahead. So what is some of the objectives we want to accomplish? One, at the end of the lesson, you should be able to explain the hydrolysis of an ester. In addition, you should be able to explain the saponification of fats and oils and distinguish between soapy and soapless detergents. All right, I think for this first portion of this video, this lecture, we're going to at least be able to answer the two objectives firstly, and then we will reconvene afterwards. Okay, so let's begin. So what do we know thus far? Let me see if I can minimize this a little bit here. What do we know thus far? One, we have, what is an ester? Anybody remember what an ester is?
Yeah, it's fat, right?
All right. So, but give me a little bit more. What exactly is an ester? Let me see if you remember. What exactly is an ester? Because we did esters before. All right. So what is one key here is how do you make an ester?
You react alkanoic acid and alcohol.
Right. So that's correct. All right. So what we'll see is that an ester is a compound formed when an alkanoic acid reacts with an alcohol. All right. So Kyle, you are correct. An ester is a fat. All right. But in terms of the definition, what we had before, it's basically an alkanoic acid and an alcohol which reacts. That forms a compound, and the name of that compound is called an ester. Khadija, you there?
Yes, sir.
All right, cool. So the next question here is, what is a distinguishing quality of an ester? How would you know an ester is an ester? That's what we're really trying to find out. How would you know? So it's very important to note this. Very key. So I'm giving you a chance. I see Khadija. Khadija, you're doing it? Khadija, you're taking it up? What are you doing? What is a distinguishing quality of an ester? What is a key thing to know about an ester that I could be able to identify? There's one word that is really quick.
Smell.
Huh?
Smell.
Right, that is correct. A smell. All right.
Oh, okay. Right.
Right. Esters are characterized basically, yeah. Anytime you hear an ester, you think about a smell. All right. If it's the smell of a banana, a smell of a citrus like orange, smell of an apple, grape, whatever these cases, these are actually esters. All right. So what happens? A key thing here to note again is that esters are volatile. Okay. So they are volatile liquids, which usually have very distinctive, sweet, fruity smells. All right, this particular is linked to the ones and then that have smaller chains. So these are smaller chain esters. They're easily, when we talk about volatile, remember we're dealing with boiling points. So they are, when we say something is volatile, it means that it has a very low boiling point. So it can evaporate quickly within the air, all right, at normal room temperature. An ester is an example of that. So there are some things where we know we can find esters, like in perfumes, examples, that's an example of one. Some fragrances that you may have for air fresheners and these things, they would use esters in these areas. All right, let's look at the next one. What are some examples of esters? So give me an example of an ester. Well, I kind of gave a few of them.
Yeah.
Nice, you know. But naturally, if we look, there are many esters in nature. They can be found in both animals and plants, especially flowers and fruits. So oranges, apples, all these fruits, these nice fruity smells, guava and all. You ever have a guava and that guava in your house and that guava is gonna smell up that place real nice? Guava is an excellent air freshener. You place some guavas on your counter and that's going to freshen up the entire air in your living room or your kitchen. All right, so esters can be found in plants, right, such as fruits and flowers, and also in animals. Kyle, you were saying, what was one of the ester you were saying?
I said raspberry.
Right, raspberry. And before the beginning, you were saying an ester is a what?
It's a fat.
Right. So we have animal fats, we have vegetable oils. All right. They are also esters, but these here are particularly what we refer to as long chain alkanoic acids, esters that contain long chain alkanoic acids and glycerol. So in here, before we note that an ester, and let me see if I could bring in that pointer here. An ester is made up of an alkanoic acid and an alcohol. So in this case, the fats from animals and vegetable oils, they are made up of long chain alkanoic acids and an alcohol called glycerol. So these two combine to make an ester. We have two more questions, I believe. One, the first question says, what is the name of the process when an alcohol and an alkanoic acid is combined chemically? Anybody? I think Khadija.
Esterification.
You all get it right on the bat. Right on the bat. So that's correct. Esterification. Esterification is correct. All right. And the last one. All right. What name will you give an ester that was combined with propanol and hexanoic acid? You have to remember how you name an ester. All right. So how do you name an ester? What is going to be the name?
Propyl hexanoate.
Right, that is correct. Propyl.
I guess that.
Hexanoate, right? That's correct. All right, remember we say that the alcohol part is going to come as a group or a branch or a substituent. So we will call it propyl. In this case, since the alcohol is propanol. And the hexanoic acid part is going to form the hexanoate portion of the ester. So very good. The answer is propyl hexanoate. So that's correct. So you guys did well, I must say. All right. So I give you guys a round of applause. Very good.
Thank you.
Yes.
Thank you.
Yeah.
Pat myself on the back.
Yeah. So what? We are going on today. We need to look at hydrolysis. All right. When we're dealing with saponification, one of the very important areas we must touch on firstly is hydrolysis. So we did an ester, and we know in order to combine an ester, we use an alkanoic acid and an alcohol to make an ester. That's what an ester comprises of. And they link and they formed this one compound which we refer to as an ester. All right, so what? Let's look at this. So during a hydrolysis reaction, molecules are broken down into smaller molecules by reacting with water. So in hydrolysis, or when we look at the word here, L-Y-S-I-S, it comes from the word lysis. Lysis means to break apart, all right? And when you look at hydro, we refer to as hydro as being water, okay? So it's breaking apart something using water, all right? So hydrolysis is basically breaking apart a molecule into different components now, or different products, by using water to react with that molecule. Now,
So question,
yeah.
why make the ester if you're going to break apart the ester?
Well, very good question. Why make the ester if you're breaking apart the ester? Why? What is that? What really here is showing how we form an ester. Could let you know how what an ester is made up of. But in nature, esters, there are esters that are naturally occurring. Remember before we said that an ester can be found in animal fat or in vegetable oils. These are naturally occurring in nature. So if you know how to break apart an ester,
Yeah.
the naturally occurring esters that they are, you can break them apart. You understand what I'm saying? So by knowing how to form it and break it apart, you can use that same process to break apart other esters that might be naturally occurring in the environment to produce different substances. All right, and that's basically what the best answer I can give you for that. All right.
Okay.
All right, so here is it. We said esters now can be hydrolyzed by heating with a dilute acid and aqueous alkaline. All right, let me just minimize this here a little bit. So an aqueous alkaline. So you can break apart an ester by one, using an acid and also using an alkali. All right, that's the same hydrolysis. So the product depends on whether the acid on the product depends on whether you use an acid or an alkali. So what happens when an ester is hydrolyzed using an acid? It is called acid hydrolysis. And when an ester is hydrolyzed using an alkali, it is known as alkaline hydrolysis. So basically we have two types of hydrolysis: acid hydrolysis and alkaline hydrolysis. All right, and this is where we build on saponification. Okay, so now we know how an ester is formed and we know how to break apart an ester. Now let's look at these two hydrolysis, because an important thing to note is that the products are going to differ with both of the reactions. There's going to be a difference in the products. All right. So let's look at acid hydrolysis. I have a nice diagram here. You see an ester and it's seeing water and it's seeing H3O plus. That's because an acid is present, and you're seeing a carboxylic acid being formed and an alcohol. So let's look at acid hydrolysis. During acid hydrolysis, the ester is heated with an acid catalyst such as hydrochloric acid or sulfuric acid. So these are the two acids that we can use, all right, for the acid hydrolysis. All right, the product will be an alkanoic acid and an alcohol. All right, because we know by carrying through the hydrolysis, we can break apart the ester, and we're going to get the alkanoic acid and the alcohol. In acid hydrolysis, you are going to have that same, you're going to have that product being produced. So example, we have acid hydrolysis of ethyl ethanoate. So this here is ester, ethyl ethanoate, and when you carry it through acid hydrolysis, we see the H plus ions from the acid, you are going to produce an acid and an alcohol. In this case, the ethyl, which is the alcohol portion of the ester, is going to produce ethanol, and the ethanoate portion of the ester is going to form ethanoic acid. All right, and this is basically acid hydrolysis. Anybody have any questions? All right, no questions. Okay, so important things to note: in acid hydrolysis, you use an acid to catalyze the reaction. All right, and in that process, what happens? You produce an alkanoic acid and an alcohol. All right, how would we know what is produced? Based on the name of the ester that we have, the ethyl portion is going to produce the alcohol, going to be is what's going to form the alcohol, and the the alkanoic part is going to form the acid. So in this case, in ethyl ethanoate, ethyl formed ethanol and ethanoate formed ethanoic acid. Let's look at alkaline hydrolysis. During alkaline hydrolysis, the ester is heated with sodium or potassium hydroxide solution. All right. Products are a sodium or potassium salt of an alkanoic acid and an alcohol. So there's a difference here. So instead of an alkanoic acid being formed, what you're going to be forming is a salt and an alcohol based on what they're saying. Now, this particular reaction has two stages. The alkaline hydrolysis of ethyl ethanoate will be our example for this, reacting with sodium hydroxide. So in stage one, what is going to happen? Ethanoic acid and the ethanol are formed first, as in the acid hydrolysis. In this reaction, what happens? It goes in steps. So the first thing that needs to occur is that the ester must break apart into its original substituents. So it must be broken apart into the alcohol and the acid first. That's the first part of the reaction. So in the first part of the reaction, we're going to have, in this case, the example we are using is ethyl ethanoate and sodium hydroxide. So this is the first part of the reaction. The water goes in because we said hydrolysis is using water to break apart a molecule. So what happens? The first part of alkaline hydrolysis is that the water is used to break apart the molecule of the ester. The molecule is broken apart into ethanoic acid and ethanol, but the reaction is not complete. All right, there's a second portion of the reaction. On the second portion of the reaction, the ethanoic acid is then neutralized by the sodium hydroxide solution to form a metal alkanoate. So what is in this case that's going to occur between the ethanoic acid that was formed in the previous stage? The ethanoic acid being present now is going to react with the base that is there, which is the alkaline sodium hydroxide. So the sodium hydroxide is going to react with the ethanoic acid to form a salt. So if you remember from acid-bases reaction, that when an acid and a base comes together, you're going to form, or an acid and an alkaline comes together, you're going to form salt and water. Okay?
Right.
So in this case, we're having ethanoic acid is going to react with the sodium hydroxide to form sodium ethanoate. Okay? And that's basically what happens here in this case. So you're gonna have that and water being formed. Okay? So if we look at the reaction overall now, in just marrying all the stages together, just putting everything going. The stages is just to let you see what happens in the reaction. But the overall reaction is written like this. When we have ethyl ethanoate reacts with sodium hydroxide, forms sodium ethanoate and ethanol. Okay? So this
question, why don't you just discard the water?
why does discard the water in the reaction?
Yeah, because on top they're saying form the salt and the water, and then below it have no water.
Right, water is there present, but what they're really looking at is the water is going to always be in the reaction there. So all of these substances, example like the aqueous sodium hydroxide is actually in water.
Oh, okay.
Right? So to say that even though we know water is produced in the reaction, it's sort of like a spectator to everything that is going on. All right? So they don't necessarily put it in the reaction. All right, and that's the main reason why. So we just look at what is actually being produced, reacted, and produced, even though the water is a product. All right. All right. So this is here alkaline hydrolysis. Now, this particular alkaline hydrolysis is what is the backbone for saponification, which is what we're going to be looking at now. Okay, so let's look at saponification. All right, so what can we get from before we go on to saponification? We learn about alkaline hydrolysis. In alkaline hydrolysis, we use an alkaline such as sodium hydroxide or potassium hydroxide solution to react with an ester. When it reacts, there's two stages that occur, but the end product at the end of the day is going to be a salt and an alcohol. Whereas in the acid hydrolysis, you have an acid being formed, which is an alkanoic acid, and ethanol. So the two hydrolysis are different based on the products that is being made at the end of the reaction. Okay. All right. So let's look at saponification. Saponification refers to the alkaline hydrolysis of large esters found in animal fat and vegetable oils. All right. Why do we use large esters? That's a big question. Could anybody tell me? I'm just trying to see if you could remember or at least come up. Why do you think we're going to use large esters? These long chains. When yeah, yes, Kylie, is saying something?
No, I'm just thinking.
Okay. So while you are thinking, let me see if I could put some ways to think in terms of that. Let me see if I could guide you a little bit. When you're thinking about it, you have to think about physical properties of homologous series. All right. So we're looking at a homologous series, and there's a difference between substances in a homologous series. When they gain, the differences that they have are carbon and extra carbon as you go down. All right.
Right.
But things as they increase in the length of the carbon chains, what happens?
The physical property does change.
The physical property does change. What about the physical property does change?
Boiling point, melting.
All right, boiling point, melting point, and what else? So we have boiling point, melting point. Yes, Khadija, you were saying something? I thought you were saying something. All right, so boiling point, melting point. What about state?
Oh yeah.
Right? The state is gonna change.
The liquid.
Right, to liquid, and then we're gonna have, as they increase, they're gonna get to a more solid form. All right, so what happens, and this is going to help you to think about the types of soaps that you're going to have. You could have hard soaps and soft soaps. Whenever you get a chance to go through the activity on Edmodo that I would have posted up, the videos, there's a video that talked about hard and soft soap and what's the difference between them. But in essence, longer chain esters are going to form solid components or solid compounds at the end. Okay, so that's one of the reasons why in this case, when we use long chain ones, we are going to have a salt that actually precipitates out to form a hard block, okay, or a solid. So in alkaline hydrolysis, this is actually what manufacturers use to make soaps, this particular process, all right, where they take the fats from animals and fats and react it with an alkali. Okay, so let's look at this. So fats and oils are boiled with concentrated potassium and sodium hydroxide solutions to produce salt of long chains alkanoic acids, also known as fatty acids. All right. So what happens here? What happens here in this case? you're seeing the fatty acid, right? Known as fatty acid. The fatty acids will be the alkanoic acid portion, okay? So now other products of the reaction is the alcohol, glycerol, and glycerol has 3 hydroxyl groups. So we've seen glycerol on the side here. I'm going to give a better picture as I do a little drawing on the board, okay? So I'm going to revert to the camera so that you could be able to see clearly what exactly is it that I want you to see. All right, but I'm going to tap on it as we go further, but note carefully is that in the saponification process, these fats, which are esters, contain an alkanoid part and a alcohol part, which is an alkyl part, okay? And they need to, in alkaline hydrolysis, they are broken apart. When they are broken apart first, the alkanoic acid portion that is going to form is going to react with the base. And when it reacts with the base now, you're going to form a salt. The salt that is formed there is the soap that we want to get. So you're going to realize here from this that the salt here in this diagram in saponification, an acid, the oil, the base, which is the lye, going to react to form the salt, which is the soap. All right, so let's look at an example here. So simplified, oils react with sodium hydroxide to produce a salt, which is of a long chain alkanoic acid, and glycerol, which is the alcohol portion. So we're going to look at this particular one. There's a fat which is called glyceryl octadecanoate. All right, and this is its formula here. And the glyceryl octadecanoate is an ester of fatty acids known as octadecanoic acid and glycerol. So I'm going to take a drawing on the board. Let me see if I could bring up my camera here. I should have done that. And we are, so you all see my camera, right?
Yeah.
Yeah.
All right, so good. So we said that we have in the ester, right, where we deal with glyceryl, decanoate, right? So we're saying that it contains the alcohol portion. This is the glycerol part, which is actually glycerol, and the formula for the glycerol octadecanoate is going to be C17H35 COO in brackets 3 C3H5. Right? This is the formula for this particular. So you all seen it clearly?
Yeah.
You're seeing clearly, right?
Yeah.
Yeah.
Right, just making sure. All right. So what happens here now is that this now contains 2 portions. It contains the glyceryl portion, which is glycerol, which refers to the alcohol. And this is how glycerol looks. Glycerol has 3 carbons in it, connected to 3 OH groups, and each carbon has hydrogens on them. All right. So this is the glycerol portion. So I'm just gonna erase the H's because I need to connect them with to form this particular ester. All right. So we're gonna come back to that after. So the ester that is connected to here is one that is called octadecanoate. All right? And in this case, there's 3 of them connected to the molecule, connected to these portions here. All right, so we have 17 carbons. So I can draw 17 carbons going straight down, or I can use a line method. And line method is going to make it easier in this case, where each junction represents a carbon. So, all right, so we have 1, which is going to be this first area here. So let me see if I can start at the one at the bottom here. This is 1. Let me start at the top. So this is 1, 2, 3, 4, 5, 6, 7,
8.
Wait, hold on. Before I go, I'm missing something important.
So the hydrogen.
The OH part.
COOH, yeah.
All right, so it's going to be this bonded to a carbon. The carbon has a double bond here. So I'm going to still represent them like that. So this is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right. Same here for the next one. It's going to be carbon here. This carbon here is 1. Double bonded to an oxygen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Just as in this case here again, double bonded to the O. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so this here is actually glyceryl octadecanoate. That's this entire molecule here. So it looks complex. It's not something that you really need to learn off your hand, but there's something that I want you to take a note of that is very important, and that is this area here. This area here, which is the ester bond, which shows the link between the 2 of them, okay? So here is what happens when this molecule undergoes alkaline hydrolysis. It's going to be broken apart, all right? So it's going to be broken apart into an alcohol, which is the glycerol, and the alkanoic acid. So in this case, I'm just going to show you, just going to be doing it here now. So let's say I carry out through alkaline hydrolysis, and I'm now going to break apart the molecule. So I'm going to separate this, and I'm going to form 2 components now. So it breaks apart in two stages. It forms an alcohol. This is the alcohol, glycerol, and the next part, which I'm going to take plus, is going to be the acid, which in this case is going to be octadecanoic acid. And how is that formed? We had 3 of them connected here. 3. So I'm just going to give an example of one of them, which is in this case is going to be O bonded to an H, bonded to a carbon, double bond O. So that's 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17. And we are going to have 3 of these because the 3 of them came from here. Let me use a different color. And we are going to have 3 of those that are going to form. That's the first part of the alkaline hydrolysis. Okay? And where this is concerned now is that the second portion of the alkaline hydrolysis, which now has sodium hydroxide present, which is alkaline, all right, which is an alkaline, which we refer to as a base as well, is one of the bases that is water soluble. what is going to happen, since this is an acid, so this is an acid here, the acid will react with the base, which is the sodium hydroxide, to form a what? What we are going to form?
Salt.
We're going to form a salt. All right? So in the end, we're going to take the salt now, and we're going to just look at the products. Let me see if I can put them on top. Okay, in the meanwhile, because the board, we don't have much space on the board. We're going to form products, and these products that is going to form from the reaction of the acid, I'm just going to put them on top, is going to be sodium, right, octadecanoate. All right, so that is going to be the salt that is going to be formed. And what we have here now, if I have to draw it, it's going to look like this. So remember this first portion here, which is the carbon with the double bond O, and this O is now going to be bonded now to an sodium group. So the H, instead of the hydrogen here, is going to be bonded to sodium instead. All right, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And this here now is our salt. And this is the soap. And imagine we have 3 of them. So the sodium hydroxide, the amount of sodium hydroxide we're going to need to react with all of them would be 3 times the amount. So we're going to actually form 3 moles of this particular salt, which is the which is the soap that we want to make. All right. So I hope that at least that would have helped you there to understand that particular area. All right, so everyone is cool? Everyone is good?
Yeah.
Yeah.
All right, Khadija, let me see Khadija. All right, I'm seeing Alicia in here now. All right. So let's look at this here now. So the glycerol octadecanoate, all right, it reacts with 3 sodium hydroxide, 3 moles of sodium hydroxide to form 3 moles of sodium octadecanoate and glycerol, which is the alcohol. All right, and this is basically your salt process, which is saponification, which is production of the soap. When the soap has been produced, which is the sodium octadecanoate, the mixture is added to saturated sodium chloride solution to precipitate out the soap. So they take that additional to put it in concentrated salt solution to at least, you know, produce the soap at for the production of the soap, right? All right, so that's basically it here for soap production. All right, so we're going to break on this. I'm going to see if I could send you guys the quiz is. Let me see if I could organize and get that information for you all. I'm going to share my screen in that capacity.
Are we doing the quizzes on while we're all connected, or just whenever?
No, you could do it connected, eh?
Okay, cool.
Yeah, you can do it connected. All I just need to do is share
I'll get
the quizzes screen. You all seen it, right?
Yeah.
All right. So I'm gonna host the game. So this is basically one of our options. So everyone there who is there, you can join in. I'll see if I could probably send a WhatsApp to the others if they are are up to it.
All right, one sec.
So I'm WhatsApping the others right now. Right, so I know so far while you all are organizing that, there are some very important things that we would have learned today. How a soap is made. A soap is made by a process called saponification. All right, so I'm seeing Shawnee, she's in here now, and Alicia is in. So it's going to be a short quizzes. What we learn about saponification is basically alkaline hydrolysis. All right, and alkaline hydrolysis entails using a base in the presence of an ester, which is fats or oils, and reacting them. All right, so that reaction now will form a salt and an alcohol. And in the cases there, most of the times the alcohol that is formed is actually glycerol, which is a 3-carbon alcohol group. So, and this is very important for us to note. And in order to have the soap clarified, and in the end, you're going to take the salt that is produced, which is the soap, and put it in concentrated salt solution to precipitate out the soap, and afterwards we collect that precipitate and melt it or put it in molds to form soap. And you see different molds you could have. You could have a star, you could have a round bar of soap, you could have a square bar of soap, depending on the mold that the company would use. And this is what we use on an everyday. Now, what I could say or what I could add based on what we would have learned before is that based on the esters that they use is going to determine the physical property of the soap. Whether the soap is very hard, which is a tough bar soap, or whether the soap is very soft, or whether the soap is liquid in nature. And what is going to determine that? Anybody knows what's going to determine that?
The length of the bond.
The amount of carbon.
Right, the length of the chain. So the amount of carbons in the esters. So if it's a long chain ester, then we're going to have a solid bar. If short chain esters, then we're going to have different consistencies in state. All right, so let's begin. So you're gonna start quizzes and we are on. I wish you guys all the best. Take it away. Isha is off on the ball one time, right?
Oh, Jesus Christ.
Nice. Good, Kyle. Take your time and read carefully. Questions are can be very tricky.
No. And there's only 8 questions.
Yeah, there's only 8 questions. I said it's a short.
Oh my good Lord.
Okay, thank the Lord. Oh. One
So
sec.
far we have Alicia on top and Shawnee is in second position. Nice, Khadija, very good. Hey, I see Shanice has finished. Shanice got all right. This is what happens when you're engaged in physics. Is an excellent. Hey, somebody use a power up, boy.
Yeah. That was horrible.
All right. So far we have Shawnee's coming and Alicia coming in first position. Third position is Khadija. All right. So give you guys a round of applause. Very good. Very good.
Yeah, Kyle.
Yo, my mother came in and distracted me. Okay, that was not much. I take no blame.
Oh my. Kyle, good feet. Good fight. So let's look at some of the questions that probably was tough ones. It says, what are the two reactants needed for saponification? And of course, in order for you to carry out saponification, you need the fat of a animal or vegetable oils and a strong base, which is sodium hydroxide or potassium hydroxide. So fat and a strong base would have been the answer. If you use an acid and an alcohol, you're going to be carrying out esterification. All right, that's just to remind you all. Okay. Everyone did well for this one here. Let's look at this question. So we had one person having it wrong. What is hydrolysis of a fatty base? Of course, that's going to be saponification. All right. All right. Everyone got that one well. So let's see what other question we had that probably was. All right. Next question. Why is lye used for saponification to take place? Anybody know what lye is by any chance?
No, so what the hell is lye?
All right, so you guys
lye
will.
is not an acid. Lye is like.
I guess that's so hard. Eh? Oh my word!
Right now, here the question. Here the thing about it. If you were looking again, let me see if I could share back that slide. Where is that slide?
I hear that word lie already, but like to explain it and try to remember what it is, I can't do that.
Okay, so I'm gonna show you. I'm gonna bring up one
it's
of
something
the.
it is used in soup. Well, something it is used to make soup.
No, it's something to like
a
force of like and stuff.
Is that alky? Is that
You see the screen?
Yes, sir.
All right. You also, what are you seeing in the corner here in the picture?
Oh, the base. Okay, I get it. Oh, who was watching that? So nobody was studying that picture.
Yeah, that's what I was showing you all before. In the corner, you see oil, acid, lye, base to form the soap. Right. I know sometimes people could miss it, but lye is actually sodium hydroxide.
Okay.
Right? Lye is actually sodium hydroxide. So it's one of the it's a next name that they use for sodium hydroxide. It's a strong base. All right. Let me see next one. All right. So good. So this says, in which picture is saponification taking place? So you need to watch carefully at your buns.
That's the
Okay.
question I made.
It could not have been this one here because this is not an acid. You have to look at the functional groups, all right? And look at it carefully here. You see glycerin here, which is glycerol, all right? You could count the carbons, 1, 2, 3, all right? 3 carbons. And look at here. You seen soap here?
Yeah.
All right, so this would have been the correct answer. All right, because this is a triglyceride, and next word for triglyceride is a fat. All right, it's another type of fat. All right, and I think generally you all did the questions excellent. Very good. All right, so I want to thank you for tuning in.
You're welcome.
All right,
No
thank you guys for
problem.
tuning
No
in.
problem.
And
Thanks.
Okay.
the next time we're going to be meeting, we're going to be talking about how a soap works. Remember I told you that the slide, I didn't finish it. So I'm going
Yeah.
to finish the slide and you're going to see exactly how a soap works. All right. So
Okay.
have a wonderful evening.
Same. See
All
you.
right.
See you later.
All right. Take care.
Bye.
Bye-bye.
Bye.